All right, so this next section is on estimates and order of magnitude. Uh, when you see this, when we're looking to estimate values, we're looking for an order of magnitude. That is to have something within an order of magnitude of 10. So if I ask you how many jelly beans are in a jar, I want to know, is there 1 jelly bean, 10 jelly beans, or 100 jelly beans? And one of those is closer to the answer than the other. So I'm not looking for a very uh, accurate value. I just want within an order of 10. I'll show you what I mean by that in just a second. So a good way to do this, to estimate the physical dimensions of an object, be it the length, mass, or time, is to just have a good understanding of what those metric measurements for length, mass, and time are. So for example, a meter is about 3 feet. It's about the distance from your nose to the tip of your finger, depending on how long your arms are. Likewise, you need to know how long is a centimeter. A centimeter is 1/100th of a meter, and it's about the width of your pinky finger. Millimeter, which is 1/10 of a centimeter, or 1/1000th of a meter, and a millimeter, you know, is, well, it's, I don't know, the width of a thin wire. You can look on your ruler and see an example of a millimeter. You also need to know what a kilometer is as well. So always remember this because, let's see, a kilometer is what? 0.6 miles? No, that's not right. Yeah, 0.6 miles. Because 5K is 3.1 miles. So 5 kilometers is 3 miles. So 1 kilometer is about 0.6 miles. Excuse me. But anyway, you need to work out in your mind some way to remember what is the physical dimensions of these different measurements that we do in length, mass, and time. And of course, everybody knows what a second is. 1, 2, 3. All right, but usually we're talking about either mass or our length. So you also need to know what a kilogram is. A kilogram is a couple pounds. Typical person has a mass of about 70 to 100 kilograms. All right, that's 150 to 200 pounds. Let's do an example. For example, I'm sitting in my office right now, and my office is about 10 feet square, and the ceiling is about 10 feet. So if I were to express that in meters, I would say, well, it's about 3 meters. So the volume of this room is 3 meters by 3 meters by 3 meters. All right, which is, keeping proper sig figs, is 30 cubic meters. Now, when I would give this to you on a test, it would be multiple choice, right? I would say, well, is the volume of this room 3 cubic meters? Is it 30 cubic meters? 300 cubic meters? Or is it 3,000? Right. Now, we might have some disagreement on what, is this 2 meters or is it 3 meters? Or is it 3 meters or 4 meters? But even with that disagreement, you're going to be able to land on the correct answer. So obviously here the correct answer is not 3 or 300, it's 30 cubic meters. How many pages are in a book? Well, this is sort of like unit conversion as well. Let's say that we have a book. This is the spine of the book, and let's say that this book is, I don't know, 3 centimeters across, 3 pinky widths across. And if I were to take, actually, no, let's say that it's 5 centimeters across. If I were to take, say, 10 pages, let's pick up a book here. If I were to take 10 pages, then I would find that those 10 pages are approximately a millimeter. So I have about, for 10 pages, they cover approximately 1 millimeter, all right? Which is to say that 10 pages, 1 millimeter is 1/10 of a centimeter, is about 0.1 centimeters. So if my total width of the book is 5 centimeters, I can use this conversion factor. I have 10 pages, 0.1 centimeters. Then that tells me that in my book I have 500 pages. All right, so it's taking some known quantity, an estimate of a known quantity, that is how many pages in a millimeter's width of book, and converting that into number of pages total in the book. These are very useful when you're just sort of doing rough calculations, and we'll use these type of estimates throughout the course. We'll watch some movie clips and what have you, and you'll need to have a good way to estimate distances and masses. But we'll get some practice in that as we go along. However, you also will have questions on the exam, the hour exam, and in the online quizzes that are explicitly estimate the mass, estimate the distance, estimate the area or volume of this known object. And usually it's going to be an object that is available to you, or at least an object that's very well known. This is an example of this projection screen. I'll let you play that. All right, let's look at coordinate systems. We're going to use coordinate systems a lot in this class, especially in the first half of the class. Coordinate systems are used to define a point in space, and there are two types that we'll use. Primarily, we'll use the Cartesian coordinate system or the rectangular coordinate system. This uses x, y, and z coordinates. We measure along the x-axis. Say, for example, here I have coordinates of 2, 3. That means I move along in the x-axis 2 units and move up in the y-axis 3 units. I can add a third dimension, z, which is either into or out of the page. And in that way, I can define my coordinates. We'll take a right-handed coordinate system. That means that right is positive, up is positive, and likewise, our contrary to that, left is negative, and down is negative. Out of the page plus z is going to be positive. That's out of the page. And negative z will be into the page. We'll deal with three-dimensional coordinate systems about midway through the course when we get into rotation, and next semester in electricity and magnetism we'll deal with 3 dimensions a lot. All right. There's the three-dimensional, this is the z-axis right here. Remember, this is plus z, and this is minus z, into and out of the page. Well, also, when we get into rotation, we'll use the plane coordinate system, or excuse me, the plane polar coordinate system a little bit. This is similar, but instead of using x and y, we use r and theta, where r is the distance from the origin and theta is the angle from the x-axis. In order to do that, in order to use the plane polar coordinate system, you'll have to have a good working knowledge of trig. Now, the prerequisite for this course is to have trig, although I know that many of you have bypassed trig to take calculus, or some of you may have even been let in with just pre-calculus, but you will need to know trigonometry for this course. And fortunately, you don't need to know the whole course of trig. You really just need to know some basic right-angle trigonometry, which you probably had in high school. You did have in high school, whether you remember or not, I'm almost certain. So a couple different rules that you'll need. First, if we have a right triangle is defined as having a right angle there. This side is called the hypotenuse, and then these two sides are the legs. We have some rules defining the relationship between the angle and those three sides of the triangle. Those rules are given by this mnemonic, SOHCAHTOA. Although, let's see, somebody else told me there's another mnemonic about some old hippie something or another, but I like SOHCAHTOA. Right, to remind me what is the relationship. This says that the sine of the angle theta is equal to opposite over adjacent. So the sine of this angle is equal to opposite over adjacent. The cosine of an angle is equal to adjacent over hypotenuse. Actually, I made a mistake there. Let me go back and fix it. The sine of the angle theta is opposite over hypotenuse. So the sine of this angle theta is opposite over the hypotenuse. And then the last TOA, the tan of the angle theta, is opposite over adjacent. Those are really the only ones that you'll need. If you use cosecant, secant, and cotangent, they're really just the opposite of these flipped. But don't worry about those. You don't really need those. You'll also need the Pythagorean theorem. The Pythagorean theorem says that we usually see this as a squared plus b squared equals c squared. Let me add these. So here, that's going to be, this will be the side A, this will be the side B, and this will be the side C. So the sum of the squares of the sides is equal to the square of the hypotenuse. And that's a general rule for right triangles only. Let's see, something else that's true for all triangles is that the sum of the angles is equal to 180 degrees. And we'll use that quite a bit, especially in the third chapter. So for example, if this is 90 degrees, if this is 20 degrees, then that means, or let's say this is 70 degrees, that means that this angle has to equal 20 degrees, because those three angles have to add up to equal 180. And in a right triangle, since one of them is always 90 degrees, you know the other two have to add up to equal 90. Sometimes you'll need to find the angle theta, so you'll have particular sides of that triangle. Like you'll have theta, and then you'll need to know y, x are the hypotenuse. And or we'll need to find the angle theta rather. So we say the tangent of the angle theta, TOA, right, opposite over adjacent, that's y over x. And so if I find the angle theta, what I want to do is to take the inverse tan of both sides. That gets rid of the tangent over here, and so I can find theta is the inverse tan of y over x. We use that a lot in this course to find positions for vectors, force vectors, position, velocity, acceleration vectors, and the like. You can do similar things for sine and cosine. You can imagine, so for example, if I have sine, let's see, opposite over adjacent, over hypotenuse rather, so that's y over h is equal to theta. I got that backwards, I'm sorry, it's too early this morning. So sine of theta is y over hypotenuse. And so if I wanted to find theta, I would just take the arc sine, or the inverse sine of both sides, and then that would give me the angle theta. We'll see some examples of that as we go through. You'll see also on that first exam, you'll see some just sort of explicit, maybe one problem that's just explicitly a trig problem. And I'll just ask you, what is this side, what is this angle, something on that line. But it's going to come up over and over again as we go through the course. If you don't know trig, you really need to come see me, because if you don't know it now and you don't pick it up soon, you're going to struggle for the rest of the course. So if you're having trouble with trig, please contact me over email or phone, or call me, come see me if you're able. And I'll give you some resources to help you with trig, or I can help you with it as well. So I'm assuming that you've all had it before. There's a quick test question, something similar to what you might see on your exam in a couple of weeks. All right, that's the end of that chapter. The online quizzes will be due soon.